This session is about many-to-many relationships in Power BI. Actually, many-to-many relationships in DAX, but we will see a few features that at the moment are only available in Power BI, even though I think that they will be available also in analysis services in the future. My name is Marco Russo. I write articles, books about DAX, Tabular, model, analysis services. You can find a lot of content on sqlbi.com. And you see the book we are writing about DAX, the second edition of the definitive guide to DAX that should be ready around mid of this year. We had to wait to complete this book until the feature that has been announced yesterday for the calculation groups. But today we're going to talk about relationships, and we're going to talk about different types of many-to-many relationships. I will try to explain why what is called many-to-many in Power BI today, there is a kind of relationship called this way, is in reality something that we would like to call in a different name, even though we don't have a good name. And I will try to show you the different type of data modeling issues that we have to face in creating any analytical solution, and how we can implement these problems, these patterns, in the tabular model, and so in Power BI. So we will start with the many-to-many relationships between dimensions, which is what we usually, in the business intelligence world for many years, has been always assumed like the only many-to-many relationship that we can have. Many-to-many relationships between business entities, customers and accounts is the example I will show you in a few minutes. And we will see other type of relationships that we have in Power BI that actually manage the cardinality of the relationship, which is a different thing. We have different cardinality in a relationship in Power BI, like one-to-one, one-to-many, and recently many-to-many, that cannot be confused with a many-to-many relationship between dimensions. So in the next 45 minutes, I will try to explain you what is the difference and make you aware of what is the right choice you have to make when you design your data model. So we start with the classical one. What is a many-to-many relationship between dimensions? And the idea is we start from a business issue, a business problem. We have two or more business entities that cannot be related in a simple one-to-many fashion. For example, imagine what you have in a bank. You have bank accounts, you have customers that own the bank accounts. Now, one bank account can be owned by multiple holders. But when this happens, for example, I have an account with my wife. Wonderful. However, my wife, while I'm speaking here, she can go to the ATM and withdraw the entire amount of the account. I could have done the same yesterday night, however, and 1 minute later, the other owner of the account cannot get any money, which means that the amount of the account cannot be split across the owners. We cannot say I have 50%, she has 50%. We cannot say I have 70% and 30%. So we have to figure out what is the way we can manage this relationship so that the transactions or the amount, the balance of the account is available to all the owners, but when we evaluate all the bank account owners in this room, if someone of you has a shared bank account with someone else, we cannot count the same account twice. So if we want to sum the amount of money available in all of your accounts, we cannot count the same account twice, which means that the classical join between tables will not work. Now, if we think about the data we have to manage, so before we look at the content of the tables, just figure out about what are the business entities that we have to manage here. First of all, we have the customers. Imagine we have a list of 4 customers. Marco, Paul, Robert, Luke. And these 4 customers own one or more accounts, we have another table with a list of the accounts that here I listed just as 1, 2, 3, 4, 5, 6. If I look at these two tables, I don't have enough information to establish what is the relationship between these entities. Two tables are not enough. We need another table. We need another piece of information to establish what is the right correlation between customers and accounts, which means that we need a third table that we can call accounts customers. We can call a bridge table, factless fact table. If you know the dimensional modeling, the Kimball dimensional modeling, in a very ancient time it was called a factless fact table, then it was renamed to a better name, I think, a bridge table. And the bridge table is this table in the middle that acts as a bridge between the customers and the accounts. And even though it doesn't contain any measure, it doesn't contain the percentage, how much of the account is of Marco, Paul, and Robert, and so on, the presence of a row in this table establishes the relationship between the two dimensions. When we import this table in a relational database, SQL Server, Oracle, Access, what we define is a one-to-many relationship between customer and accounts customers, and another one-to-many relationship between account and accounts customers. This table in the middle is called the bridge table, and the pattern that we see is a pattern that I call one, many, many, one. If you think about the path that connects customers and accounts, at a very high level, these two dimensions are connected through an artifact that is made by two relationships and a table in the middle that if you navigate through the two relationships, you will see one, many, many, one. This is the path that you have to do. And in order to create this relationship, you need a table that you cannot obtain by the two original tables, customers and accounts. You realize that we need the accounts customers information in our data model. We cannot remove the table in the middle. Make sense? If I import these three tables in Power BI plus an additional table with the transactions, summing all the transactions, I will get the amount, the balance amount of the account. And so this is what I have here in this model that I'm going to show you. We have my transactions here, which is just a table that has account and amount. We have a table accounts, we have a table accounts customers, and we have a table customers. Once I import these tables in Power BI, and let me take a look at these tables. These tables have this content. So we have the customers table, Mark, Paul, Robert, and Luke. And by the way, I have this wonderful feature here. No, it doesn't work. Okay, oops. Bad idea, Marco. So let me go back here and let's use the classical zoom. So we have these four customers here. Then we have a table with the list of the accounts. In this case, to make the understanding, to improve the understanding of what we're going to see, instead of using numbers between 1 and 6, I put the name of the owner of the accounts. Even though the name by itself doesn't tell me anything, I need an intermediate table here, which is the accounts customers, which contains the relationship between the customer and the account. So if a customer has two accounts, I will see two rows. If an account has two customers, I will see two rows of that account. And if you notice here, the customer Mark has three accounts. This one called Mark, Mark Robert, which is an account shared between Mark and Robert, and finally Mark Paul. So far so good. Simple, we have the information, but what happens if we create a report? Well, when I create a report, I have this situation. So let me remove 1 second the customer here. If I look at this report, this is what I have. For each account, I see the sum of the amount of the transactions for each account. If you do the math, the total that you see at the bottom corresponds to the sum of all the rows that you see in this report. So far, so good. However, if I replace account in the rows with the customer name, what happens? Well, this is what happens. I always see the total of all the accounts. What I would like to see is the sum of the accounts owned by each customer. But out of the box, this doesn't work. Why? Because in Power BI, a relationship is just a way to transfer a filter, which means that in my model, this is the same model you have seen in Power BI, when I filter a customer, which is exactly the situation I have now in my report, the filter I apply to the customer name filters the accounts customers table, one-to-many, filter propagation. However, this filter does not propagate to accounts because by default, the relationship I have, one-to-many, is a single filter, is a single direction filter, which transfers the filter from accounts to accounts customers, but not the opposite one. So I would like to do this propagation of the filter context, but this is not happening by default. What are my options at this point? Well, we have one option. Actually, we have two options. We have probably more options, but we will explore only the options that the data model, the tabular data model, allow us to implement in two different techniques. The first one is we can change the direction of the filter propagation, the cross-filter direction of the relationship. If I go in my diagram view and I double-click the relationship between accounts and accounts customers, you will see that this dialog box shows me cross-filter direction, which is single, which is the right thing to do. Use single. But just for this demo, I could switch this to both. When I do this, what happens? Now I'm instructing the data model to transfer the filter from accounts to customers, from accounts to accounts customers, or from accounts customers to accounts. In case there is a filter filtering accounts customers, this will propagate to accounts. As you can understand, I'm not suggesting you to do this easily in a model, but for this specific case, for this specific demo, we can do that. Alberto had a session yesterday. If you didn't attend the session of Alberto yesterday, you can watch the recording in a few weeks on the website, explaining why enabling a bidirectional filter in the model, like I'm doing now, could be a dangerous operation. Dangerous if in the future I will add other tables in this model. If I can guarantee that I will never add any table to this model connecting to accounts or to customers, this is safe. For this demo, it's safe. For the next 30 minutes, it's safe. So we can go ahead. So now, because I changed this propagation of the filter, what happens? If I go back to my report and I didn't write any line of DAX so far, we see that now for each customer I see the sum of the accounts of the customer. Why? Because the customer Luke propagates the filter to accounts customer and propagates the filter to the account name. And if I include the account name in the same visualization here, you can see that if I drill down, this is what I have. Let me see. I can see that Luke has only one account. I can see that Mark has 3 accounts. I can see that Paul has 2 accounts and Robert has 2 accounts. Wonderful, it works. However, every time you enable a bidirectional filter in your model, when you use a measure, an aggregation that is affected by this bidirectional filter, the measure is no longer additive. What does it mean? Pay attention and do the math. I know it's early in the morning, but you can do this. If you sum these numbers, if you sum each customer, the number, the total you obtain is bigger than 8,000. Do the math. 4, 6, 7, 8, 9, is around 9 something, 9,000 something, okay? Why this happens? Well, if I drill down, I can see why this is happening. For each customer, each account is counted only once. But the same account, for example, Mark Robert, is present twice. the account marked Paul is present twice. In the grand total, these accounts are counted only once. So we are not inflating the number of the total because we are not summing the customers. We're still summing the accounts. Okay? So this is something we can do just using the data model. Now, in the real world, I never have only 4 tables. And so this is usually a bad idea unless, as I said, I can guarantee I will never add other tables here. So what is my other option? My other option is I keep this as a single direction and I create a measure. Let me create another measure, so because now I see that now the number is always 8,000. If I go in my transactions table and I create a measure, amount many to many, and I can write calculate of the measure that exists, and I can enable the bidirectional filter just for this calculation. There is a special function that I can use only within calculate that is called CROSSFILTER. CROSSFILTER has 3 arguments. The 2 endpoints of the relationship, for example, accounts customers account and accounts account, these 2 columns must correspond to an existing relationship in the model, and the 3rd argument can specify what is the direction. If I say both, it is a bidirectional filter. None, I disable the filter propagation like I disable the relationship. One way, single direction. You can include both in this case. You can specify both in this case. And what happens at this point? Even though my model has a single one-to-many relationship with a single direction, just for this calculation, the behavior of that relationship will be bidirectional. If you look at the result now, if I include this amount many-to-many here, now you see that the numbers presented by this measure, let me just fix the format here, the numbers presented by this measure correspond to the numbers I had when I enabled the bidirectional filter in the model. From a performance point of view, this solution using CROSSFILTER provides you the same performance benefits of enabling the bidirectional filter in the model. But we do not have any side effect on other measures of the bidirectional filter, which is the danger I was mentioning before. Okay, so usually this is the situation I prefer. I go this way, and this is the report I want to use. Sorry, let me remove this one. I can include the account, I can drill down, I can see my data, everything works fine. What I've shown you always worked since 2016. We didn't use any new feature, but this is what we usually consider a many-to-many relationship. A many-to-many relationship between 2 business entities, 2 dimensions if you prefer. In this case, customers and accounts. And a CROSSFILTER solution is what enabled this index. Now, we can have other scenarios, and we can have scenarios where we cannot establish a one-to-many relationship. The one-to-many relationship requires one side of the relationship to be a unique identifier in the table. The column you use on the column you use on the one side of a relationship must be unique in the table, must be a candidate key or a primary key of the table. Every row must have a unique value. Sometimes this is not the case. And this happens very frequently. For example, imagine a scenario where we have the budget. We have sales and budget in the same data model. Usually, we have sales at the maximum level of detail. Each transaction made by a customer for a product in a particular day, in a particular store. However, when we define the budget, usually we don't have a definition of the budget at the same level of granularity. The budget is a gamble. I mean, we try to guess what will happen in the future, but actually nobody knows. And in order to reduce the error, we try to define a budget not at the level of how much phones will I sell in this store that day. We will say, okay, more or less in this month, you will sell around 100 phones of any manufacturer and any model. We don't go at the detail of the color of the model of the vendor, okay? This is the way the budget is created usually. But this creates a problem in the data model, because now the budget table cannot be joined to the customer table or to the product table. For example, consider what we have here. We have a budget table that has, for each country is a group of customers, and each brand is a group of products. We have an amount, budget. And we also have a scenario that says, okay, we have three budgets. In reality, we have a scenario optimistic, pessimistic, something in the middle, something like that. In this case, we don't have the date, but we could have the same problem for the date. We could have the budget we have here is by year, but actually we have the budget, we have the sales by date. Now we want to consider in this example only the problem for the budget for products and the customers. If you look at the data model now, you can imagine that the brand and the country are two columns that exist in the customer and product table. So from a certain point of view, we could say, well, we could establish a relationship between customer and budget, because if I see all the customers in Italy, for example, I want to see the budget, so I can compare the sum of the sales made in Italy with the sum of the budget for Italy. I can do that. So there is a opportunity to do this, and the same happens for the product brand. But from a technical point of view, we were not able to define these relationships in Power BI. Because a one-to-many relationship cannot do that. One-to-many requires the one side to be unique, and we have multiple customers for the same country and multiple rows in budget for the same country. The same happens for the brand. So what happens if we don't have the relationship? We can see what happens. I have a model here, which is exactly the same model we have seen in the slide. Budget, customer, product. At the moment, I don't have any relationship. What happens if I create my report and I include here sales? I created a measure that filters just 1 year, so I can compare the sales of 1 year with the budget of 1 year. And budget is just a measure. Actually, it's not a measure, it's an implicit measure. I just got this budget column and I moved the budget column into the report, which means that now we are looking at the sum of the column budget here. Why we see always the same value for every product color or for every product brand? Let me replace this with a brand. For each product brand, I have a budget, but what I see here, sorry, I made a mistake. I used the brand. I should have used the product brand here. Okay. If I use the brand from the product table, brand from the product table filters the product table that filters the sales table. For this reason, I see here that this column is filtering sales, but not budget. What is happening? I filter a product brand. This filter propagates to sales, but the filter does not propagate to budget. I could replace the product brand here with the budget brand, because a brand is a column of the budget table. But if I do this, what happens? Now I'm filtering the budget column, the budget measure, implicit measure, but I'm not filtering sales. Same reason, I'm using the column on the other side. So what can I do to fix this problem? Because now the problem I have is that I have a missing relationship. Here we go. We have a missing relationship between the two tables. So if I want to use only one-to-many relationship, I have to face the problem. But before doing this, I can use DAX. I mean, a relationship is just a way to transfer a filter. And I can transfer a filter using DAX if I want. How? Oh, I have many ways to do that. But first of all, I have to replace my budget implicit measure with a measure I write so I can control with DAX what happens to the filters. So I create a measure here, budget. So let me just increase the font here. My budget is equal to, oops, calculate. And I have many techniques I can use. And for example, let's start with some. We start with the sum of the budget. Now I just create a measure that corresponds to the measure budget we have here. So if I replace this column budget with the measure my budget I created now, I will see the same result. Let me just format this so that it is it looks similar to the value we have seen before, 2 decimal. Okay. Okay, so this is my budget. So far, so good. Now it is filtered because I'm filtering the budget brand, but my goal is to hide the budget brand and use the product brand, because probably I want to, let me do this. What I want to do is something like I want to see for each brand, product brand, I want to see sales and budget, comparing them together. Also because this is the only way you can create, for example, a bar chart, right? You need a common shared attribute to compare two measures into tables in a single visual. Now, how can I change my budget so that it can be affected by the selection I made in the product brand? Well, I have different techniques. I could say, well, what I want to do is that the budget brand has to be within the list of the brands selected by the user. And I can obtain this list using values of product brand, for example. If I write this code, it's very simple, but it actually works. You see that the numbers now can be compared. I solved the first issue. I transferred the filter between product and budget. Now, if I do this, what happens? Actually, if you read this code, I'm saying, give me the list of the brands selected, which for a single cell is just one brand, but if I have a slicer with multiple selection, the grand total will be a list of brands. And I check that the budget brand must be within this list. Of course, I should do the same also for the country region. So we want to check that the country region is in values of the customer country region. Now, I'm not using the country region, but this is just to show you the complete example. Now, this technique works, but there is a better technique that has been introduced a few months ago in DAX with a different function that can apply the same filter in a slightly faster way. The technique requires a function called treatAs. treatAs says, I want to get this table, the list of the brands selected by the user in the filter context, but I want to apply this list of values as a filter of this column. So technically we say that we are changing the data lineage of the column that we apply in the filter specified by calculate. We can do the same here, and we can basically write the code this way here, and the only difference, the result will be the same. The only difference is that this technique is slightly more efficient compared to the in version that you have seen in the previous slide. But basically the numbers are the same. Now, more efficient does not mean very fast. We are transferring a filter using the formula engine. In DAX, the formula engine is not the fastest, the quickest part of the engine. So let me go back to the slide 1 second. We have seen that the first way we solve the problem is using DAX. we have seen treat_as, which is a new function. Before treat_as, we would have been able to use in and use this technique. But as I said, this is not actually the best way to do that, because a physical relationship in the model would be better. Moreover, there is another problem. If I have a budget for a brand that I don't have in the product table, I will never see that amount. Even though I will see the number in the total, because the total doesn't filter anything, but if I have a new brand in the budget, it will be not displayed. Nobody guarantees that the list of the brands I have in the budget table corresponds to the list of the brands in the product table, right? Now, if you think for a moment, if I look at this problem from a data modeling point of view, I could create a table in the middle between customer and budget that is unique. If I create a table countries and I create a table brands that has one row for each brand, one row for each country, I can create two relationships to do that, right? How can I do that? For example, I can create here, let me go here, modeling. I can create a new table and I can say brands. What is brand? Well, I can retrieve the list of the two. I could retrieve the list of the values from one column, but because I said, wait a minute, I may have brands in budget that don't exist in product and the opposite. I want to get the two lists and I want to merge them in a single list, and then I want to remove the duplicated values. So I can write this using distinct union of brand from the budget and distinct from the brand of the product. So let me show you the final outcome of this. If I do this, I'm saying, give me the two lists of the unique values from product brand and from budget brand. Do the union, but union keep the duplicated values. So all the brands that exist in both tables will be present twice. I don't want to see duplicated values. Distinct removes the duplicated values in the resulting table. And the result is a list of brands, right? Now I have the list of the brands, and I create a table that has the list of the countries. Same technique, distinct, union. I show you another technique. I use distinct because I have a calculate table in an empty filter context actually provides me all the rows, but I could use all no blank row. Somebody could ask, Marco, why you don't use all? Well, if I use all, I would create a circular dependency because all could include the blank value that is created when you have on the many side values that don't exist on the one side. Long discussion. Yesterday's session of Alberto explains this problem in more detail. So this is the other technique is completely equivalent. So don't worry if you, not customer, but brand, budget, country, region, this way. Now I have the list of the countries, I have the list of the brands. If I go back to my model, what I can do, I can move these two tables in the model here, and I can create the missing relationships. Because now, this is a many-to-one relationship. What are you saying? And this is, okay, and this is the country region go here, the other one too many, right? I do the same for the budget. Sorry, for the brand. Brand and brand. Now, at this point, if I use the country region column from the countries table or the brand column from the brands table, I will filter both tables and I will obtain a number that works even though I don't write any line of DAX. Because if I go back here, now I replace this brand with the brands brand, my new column brand from the brands table, and I put this table here, and it works. You say, Marco, it works because we wrote some DAX code. I know, but if I remove my code now, if I remove everything here, I just go back to my sum of budget, it just works. Because I'm filtering the table that propagates one to many, it just works. Okay? Now, it works, and it also manages the case where I have a brand in the budget that doesn't exist in the sales. What is the problem now? Because this works, and this works also if I use just the budget column here. It just works. Not bad, but from a usability point of view, the user will not like this, because the user says, wait a minute, Marco, I have a brand, and brand, too many brands here. We could say, okay, you can hide the brand from the product, you can hide the brand from the budget, and you have to use this. But the next question is, wait a minute, why I have a few attributes of the products in a table, and other in another table is confusing? Makes sense. And so once we have this situation, and let me go back to the slides one minute. Once we have this situation, we have this model now. And if you think about this model, we obtain this model by creating two calculated tables. And these two calculated tables don't have any additional information. The tables we created, I know, we created two tables. And you say, oh, we could have created this table in SQL. But I want to highlight that I didn't need to import any new data. This is important because if you think about the previous model, the many-to-many between accounts and customers, I needed a table that came from the data source. Without that table, I didn't know what was the relationship between accounts and customers. Here, I'm creating a table to solve a technical issue, but I'm not adding any additional information to the data model. This is very important. Now, we created an artifact that allowed the user to filter by using that special column, additional table, additional column. But we say, yes, but it's confusing for the user. So, assuming that we don't have the problem of having brands in the product that don't exist in the budget. Okay, sorry. Brands in the budget that don't exist in the product table. So if we know that we can rely on the list of the brands we have in the product, we could say, Marco, can we obtain a model where the user only sees the brand product? I want to hide this table. I don't want to see this table. I want to hide this table. And I also want to hide the brand in the budget table. I just want the user to use, so let me go here, let me remove this one. I want to use the product brand in the rows. Now, if I use the product brand in the rows, this is not working, because I filter product brand, but the relationship between product and brands is a single direction. If I filter a product brand, I don't filter brands. So how can I transfer the filter from this table to this table? Wait a minute. We have seen a technique in the model, which is the bidirectional filter. I can change this to both. And if I do this, from a very high level point of view, I'm generating a physical relationship between product and budget in a single direction, because product filters budget, but budget doesn't filter product. Ignore for a moment the brands table. If you look this at a very high level point of view, is a relationship between product and budget that transfer the filter in a single direction. We created an artifact using two relationships and an intermediate table that allow us to obtain this filter transfer, because remember, we are just transferring a filter. And now, because of this, it works. My budget is sum of budget. If I use the budget column without any DAX measure, it works too. It just works. I'm transferring the filter from product to brands. And I didn't use any new feature. This was working 2 years ago. No problems. I repeat the same for country region, so I go back here, I enable this, and at this point I would expect one question, which is, Marco, wait a minute. 20 minutes ago, you said don't use bidirectional filter in the model. I just said don't do this. Now I'm doing this. Why? I know that I created this bidirectional filter with one specific purpose, which is transferring the filter from customer to budget. And I know that I will never ever add other relationships to the country region table. And at a very high level point of view, I don't have a bidirectional filter. I have a single direction filter between customer and budget. Make sense? It's an art, it's a technical artifact to obtain a different result. And if you look at the relationship we have between customer and budget, the relationship is many, one, one, many. If you remember what I showed you before, 30 minutes ago, it was one, many, many, one. Now is many, one, one, many. It's different. Now, a few months ago, Microsoft introduced the composite models. And composite models allows to include tables from different direct query data sources. As a side effect of that, they introduce a different kind of relationship, which is a relationship that can have a many-to-many granularity. What is a relationship at the many-to-many granularity? Look at this. We are joining product brand to budget brand with a many-to-many granularity. We created this manually. Now look at what I'm going to do. I remove this table, delete, and I connect brand to brand. And I obtain this, where I specify that product filters budget. I don't want to use this default, is totally wrong. Don't do that. Don't use both. You want to do this, product filter budget, and want to activate this relationship. Because the default sometimes is not very comfortable. Now, if you look at what I have now, is my high-level relationship that I described before. So I can obtain with a single step the same result. Technically, it's not the same. Technically, the previous implementation is faster than this one, but the difference is close. If you have less than 10,000 unique values in the relationship, you can use this kind of relationship. You will not notice any difference. I like this feature. But I have to know what I'm doing. I can do the same here. And I remove this, and I connect the country region to country region. And I specify the direction. Remember, the direction is always both, but it's wrong. We don't want to do this, and we want to keep this relationship active. If you keep both active, you will certainly enter into an ambiguity problem, and you will have to make a few relationships inactive. Okay? Done. It just worked. So this is the kind of relationship that has been introduced that solves a specific granularity issue. We don't have a many-to-many relationship between two entities. We have a problem of connecting one dimension product to one fact table budget without the granularity of the product dimension. And to solve this problem, we used a different kind of granularity in the relationship that is still a single direction relationship between dimension and fact table. We are not creating a relationship between two dimensions. We are creating a relationship between a dimension and a fact table. Okay? So let me go back to the slides to recap what we have seen. So this is what we created in using the bidirectional filter, using the intermediate calculated table. The calculated table acts just as a way to transfer the filter automatically between customer and budget, between product and budget. And we have seen that the new kind of relationship today available only in Power BI, because pay attention, if I go back one slide, this model can be created in analysis services. 2 years ago, it works. This model today can only be created in Power BI, but technically it's the same thing. You are saving 1-2 minutes, okay? You're not saving much, but it's used. I mean, if I can use this feature, I use this feature. I'm not saying to not use this feature. So let me recap what we have seen. In this case, we have a product, which is a table that has a list of products. Then we have a budget, that is a table that has a list of budget assigned by brand. What we did, we created a table with the brands, but the table I added was obtained automatically. It is not a table that comes from the data source. It's a table that I can obtain with the data I already have. And the relationships between these tables are many, one, many. At a very high level point of view, product budget is many, many granularity, but we don't call this a many-to-many relationship, because actually it's a ugly name. It reminds me of this. And the difference is the following. In a classical many-to-many relationship between dimensions, we have two dimensions, like customer and account, and we have a table that must come from the data source that include additional information. Without this information, we are not able to establish any relationship. And the relationship we have between customer and account is a many-to-many relationship that is implemented through one, many, one. If you look at the path, is one, many, one. The second case is a relationship at a different granularity. And this requires an intermediate table that we can obtain automatically, but the relationship between the two entities, in this case product and budget, is obtained through the pattern many, one, many. At a very high level point of view, we call them many, but in reality internally, we're doing this. Remember, check the correct filter direction. Because when you create a many granularity, 99.99999% of the times, you want to create a single direction filter, not a bidirectional filter. And so think about what do you want to do at a very high level point of view. You want to transfer the filter from product to budget. And this corresponds to a bidirectional filter on the side where you want to transfer from product to budget, so product brands is bidirectional, and then the brands budget is single direction. So the single direction we created there correspond to bidirectional and single direction in the artifact we created. So I wanted to explain you today what are the different type of many-to-many relationships we have in a data model. And the many-to-many relationship called as a type of relationship in Power BI is just a type of granularity. And it requires an intermediate table that in reality does not contain any additional information. The bridge table is just a normalized attribute, like a snowflake schema. In the classical many-to-many relationship, we need a bridge table that comes from the data source. Okay? We have seen that this new kind of relationship in Power BI can be obtained using a simple relationship, but of course, it's useful, it's something that if you know what you're doing, can be used in a safe way. Please remember, use the evaluation form, provide feedback to the conference, to the session, Thank you very much for attending. I'm available for your questions in the next minutes.